Okay, after the completion of chapter vectors, now we move to next topic, which is three-dimensional geometry. In previous year, we also studied about three-dimensional geometry, but it was with respect to Cartesian part. Now we are studying three-dimensional geometry with respect to vector part. In this case, we first of all study three main concepts, which is direction angles of a line, direction cosines of a line, and direction numbers, or better to say direction ratios of a line. Okay, this is a line. When we draw a line, it surely either you can say intersect with the coordinate axis, or it may not. Okay, but in all the cases we can say some of the angle is formed. If it intersects, it will form the angle. If it does not intersect, it is parallel, then angle formed is 0, we can say. Okay, so when a line makes angles with positive direction of x-axis, positive direction of y-axis, and positive direction of z-axis, these angles are known as direction angles of the line. Okay, what are direction angles of a line? Angles made by a line with the positive directions of x, y, and z axis respectively. Okay, these angles are generally done by alpha, beta, gamma. Now you can see this line L. Okay, it is making angle alpha with x axis, it is making angle beta with y axis, and it is making angle gamma with z axis, positive directions. Okay, so these are known as direction angles of a line, denoted by alpha, beta, gamma. Okay, last year when we are dealing with the chapter straight line in case of Cartesian part, in that case we studied a concept known as inclination. What is inclination? It is denoted by theta, and it is angle made with the positive direction of x-axis. Okay, in the same way here you are having direction angles made with the positive directions of x, y, and z axis, generally denoted by alpha, beta, gamma. Now when we apply trigonometric function cosine to these angles, we get cos alpha, cos beta, cos gamma. These are nothing but direction cosines. Okay, direction angles, if you apply cos function to these direction angles, we get cos alpha, cos beta, cos gamma. These are nothing but these are direction angles, denoted by L, M, N. Means L is cos alpha, M is cos beta, and N is cos gamma. Okay, again there exist three real numbers. Okay, there exist three real numbers which are proportional to these direction cosines, okay, and those numbers, those real numbers, are known as direction numbers or direction ratios of a line. Okay, there will exist three real numbers which will be proportional to cos alpha, cos beta, cos gamma, and these numbers denoted by A, B, C, these are known as direction numbers or direction ratios of a line. Means L upon A, L is cos alpha, is equal to M upon B is equal to N upon C, or one can write in this way also, A upon L, this is equal to B upon M, this is equal to C upon N. Okay, so direction angles made by a line with the positive directions of x, y, and z axis respectively. If we apply cosine function to this, then we get direction cosines denoted by L, M, N. L is cos alpha, M is cos beta, and N is cos gamma. And the real numbers proportional to the direction cosines, means L, M, N. These are known as direction ratios denoted by A, B, C. Okay. Now, these coordinate axis, x axis, y axis, and z axis, these are nothing but these are also lines only. Now, if we consider x axis, angle made by x-axis with y-axis is pi by 2. Angle made by x-axis with z-axis is pi by 2. Okay, so value of beta will be pi by 2, value of gamma will be pi by 2. Coming to value of alpha, if we consider positive direction of x-axis, then angle of positive direction of x-axis with positive direction of x-axis will be 0, and angle of negative direction of x-axis with positive direction of x-axis will be pi. Okay, so if we consider the direction angles of x-axis, means angles made by x-axis with the positive direction of x-axis, y-axis, and z-axis. Okay, this will be either 0, pi by 2, or it will be pi by 2, pi by 2. Okay, see, pi by 2, pi by 2, pi by 2, pi by 2, angle made by x-axis with y and z. Y is angle pi by 2, z is angle pi by 2. Positive direction of x-axis makes angle 0 with positive direction of x-axis, and negative direction of x-axis makes angle pi. Okay, so these are direction angles of x-axis. If we apply cos to these, okay, we get 1 0 0 or we get minus 1 0 0. Okay, so these will be direction cosines. This will be direction cosines. Proceeding in the same way for y-axis, the direction angles will be pi by 2, 0, pi by 2. This will be for positive axis. For negative axis, pi by 2, pi by 2. Okay, as far as direction cosines are concerned, 0 1 0 or 0 minus 1 0. For z-axis, it will be pi by 2 0 or pi by 2 pi. And direction cosines 0 0 1 or 0 0 minus 1. Okay, so for a line, these three important definitions: one is direction angles, other is direction cosines, and third is direction ratios. Okay, please note it down.